Hello everybody, this is Matt from Megalomobile, and today we're going to be taking a look at some basic enemy AI. This tutorial will show you how to create an enemy that independently aims at and fires towards the player, while simultaneously completing two separate animations. We're going to set up the whole scene, cover moving the player, animating the enemy, programming the AI, and then we're going to pull everything together to create the simple but addictive game that you can see me playing with in the background right now. If you want to play yourself, there is a link to an online version in the description. If you want the completed scripts, then they are linked down there too. If you want to skip the whole video, open up a Unity package that contains everything and have a look around to see what I've done for yourself, then I've also included a link for that as well. Ready? Let's jump right in. Now, despite this being quite a primitive looking game, we're still going to need an art asset. So for this one, I've created a small 1x1 pixel white square, which we're going to use for everything. We can resize it and recolor it in Unity. So open up Unity and create a new 2D project. I'm calling my one Animated Auto Aim. You can call yours whatever you like. Once you have Unity open, you can then drag your art asset into your project folder and then drag it again onto the scene. Here you can resize your art asset. I've decided to make mine as high as one world unit and as wide as one world unit as well, just to make things nice and easy. You can resize yours however you see fit, but I chose to do this just to keep things simple. Now that you have your art asset in place, I'm going to change mine, call it player, and then going to copy and paste it and then use it to create everything else. So here I've got the floor, here I've got the ceiling. I'm going to copy paste that and make a wall. I'm going to rename them to what they are as well and sort of resize them so they fit nicely. Then I'm going to copy and paste the player again, and I'm going to make an enemy. The player I'm going to turn blue, the enemy I'm going to turn red. And then within the enemy, I'm going to create two child game objects. The first one called weapon pivot, and then child of that is weapon. I'm then going to make the weapon for the weapon itself, and that's going to sit on top of the pivot, which you can see I've highlighted there so we can line the weapon up nicely. And the final component of the weapon is a child game object of the weapon itself, which shows where the pointy end is, so I know where to spawn the bullets when I want them. After a quick test of a scene, I can give the player, the walls, the floor, a 2D box collider and a rigid body 2D, set the walls and floors to static and the player to dynamic, and then I'll have a quick tidy round on my hierarchy, just put all the background objects in their own game object called background. Next, I create a canvas so I'm able to display the scores. It starts off massive, so I set it to world space and I resize it to fit the screen. Then I'm going to add some text UI elements to this canvas. Again, they start off massive, so scale them down. I find 0.01% works great in both the X and the Y direction. And then you can just use the font to scale it to the size that you're looking for. And then I copy and paste the exact same elements into different areas of the screen, rename them hits, time, best time, just so that we've got a good understanding of where everything is. And you can see next I'm going to set the player's rigid body 2D to dynamic like I said I would earlier, and just give it a test on the scene and watch it fall. There we go, perfect. Now this game wouldn't be very fun if we couldn't control the player, so I'm going to create a new script, attach it to the player, and have that control the player's movements. So the first thing I need to do is set a public float. I'm going to call this one speed and have it start at around 4, a private rigid body 2D, RB2D, and then in the start method I'm going to say RB2D equals get component rigid body 2D, and then rather than using an update, I'm going to be using a fixed update to keep everything in time, and I'm going to say float move horizontal equals input.getAxis horizontal. I'm then going to take the rigid body 2D's velocity. I'm going to have that equal a new vector2, and that takes in an X and a Y coordinate. Now for the X coordinate, I'm going to make that the speed times move horizontal, and the Y I'm just going to keep as whatever the rigid body's current velocity is. And that's going to let me use Unity's inbuilt getAxis function to move my player, and I can adjust however fast I want him to go by changing the speed in the editor. I also want the player to be able to jump, so I'm going to create a way of doing that within script. I create a public float and call that thrust. 100 works well here. A public float maximum jump time, 0.1 float. A public bool jumping, and a private float, we'll call this one jump timer. This allows me to use the time the player is pressing down on the jump button to determine how high they jump. So if I write if input.getKey, keycode.upArrow, and jump timer is less than or equal to the maximum jump time, then jumping's true. I'm going to get the rigid body 2D, I'm going to add a force, and it's going to be vector2.up. I'm going to multiply that by the thrust. In the fixed update, I'll say if the player is jumping, then jump timer plus equals time.delta time. So that just creates a timer that times whilst the player is jumping, and we can have a look and see it in action here. There we go, nice big jump. But of course it only jumps once because now the timer is too high. So I need a way to detect when the player lands back down on the ground. So I'll say void, on collision enter 2D, collision 2D col, and if col.collider.gameobject.tag is equal to floor, then I can reset the jump, and I'll create a method for this. So void reset jump, and I'll have that jumping equals false, and jump timer is going to be equal to 0, and that should reset the jump. Now before I try that out again, I'm just going to add a couple more bits in here. So I need to set up a tag for the floor, call that floor, and I'm also going to add a physics material 2D to the floor, the walls, and the player. It's going to be called slippery, have everything set as 0 so it's not bouncy, there's no friction. And I'm also going to change the way the jump is handled in script as well, because I don't like the way he falls. I think he should fall faster than he climbs when he jumps. So I'm going to say if rigid body velocity.y is less than 0.1, or the jump timer is less than or equal to the maximum jump time, I'm going to set the rigid body 2D's gravity scale to 2.5f. I'm also going to, as part of the reset jump function, say that the gravity scale is reset to 1 once the jump's reset as well, so it doesn't float around. I'm also going to say if it's going to collide with a wall, so if col.collider.gameobject.tag is equal to wall, then I'm going to set the player's rigid body 2D.velocity to a new vector 2, and that's going to be rb2d.velocity.x, 0. This kills the upward momentum if it hits a wall. I'm also going to do something to fix the jump sometimes from getting stuck. So I'll say that if the jump time is bigger than 2 seconds, that is, just reset the jump, because you're never going to be jumping for more than 2 seconds. I then need to tag the walls as walls, and we'll give it a try. So here he is jumping around. He does fall faster when he jumps up. This makes it a bit more natural feeling when you're playing the game. And the next thing we need to do is set up a script for the enemy. So this was called enemy, and it's going to have a public game object pivot, public game object player, and a public float look speed, initialized as 50, which is how fast he's going to be looking at the player. To look at the player, he's going to need to know the direction the player is in. So to get that, you get the vector 3 direction and have that equal to player.transform.position minus transform.position of the enemy, and then you create an angle out of that. So I'm going to say float angle equals mathf.atan2, taking the direction.y, the direction.x, and because we need to get out of radians into degrees, we can multiply that by mathf.rad2deg. We take the quaternion rotation, and we'll have that equal to quaternion.angle axis, and that takes in the angle we created just now, as well as vector 3 forward. We then take the transform rotation of the enemy and rotate it towards everything we created just then at a speed that we can control. And we do this with transform.rotation equals quaternion.rotate towards, in brackets, transform.rotation, rotation, time.delta time times the look speed. Don't forget to attach the pivot and the player to the enemy script. Then we can test it out, and you can see that yes, the enemy does turn to face the player, but the whole enemy is moving, and that's not the behavior that we're looking for. Now, why is that? It's because of where we placed the script. We placed it on the enemy rather than on the pivot. So switch it round, plumb it all back up again, and there we have it. The enemy's weapon turns to face the player, but the enemy does not. So next we can look to set up an animation for the enemy. I want my enemy to spin whilst it's moving around. So I'm going to create a rotation animation. So create a new animation on the enemy and get the transform.rotation at 0, have it at nothing, and at 1 second have it rotate full 360. But looking at that, it sort of slows down and speeds up. Now, why is that? Well, it turns out that looking at the curve on Unity, you can see exactly why that is. So we can set the curve to linear on both of these nodes here, and that creates a straight line between the 2 points. So it's a completely smooth action. This means that when he spins, he completes a full circle and carries on without slowing down or speeding up, as would normally happen when you're setting up this sort of animation. Once you have your enemy all ready and spinning exactly as you'd like it, test it out in the scene and you'll see that, oh no, he's not looking at the player at all. In fact, the whole enemy is spinning around and he can't quite look at the player fast enough for the weapon to move there in time. So again, what's happened here? Well, it turns out that if you animate a game object, then the children of that game object will be animated in kind. So to fix it, just create a separate game object, called that the enemy, rename your current enemy the enemy's body, set that as a child of the new enemy game object, and then rejig your hierarchy so that the weapon is now a child of the enemy, not the enemy's body, and you can see it works just fine. So to get the enemy moving around the screen, we will need to create another animation. This time we will set the animation on the enemy itself, so it does move the weapon and the enemy at the same time. We're going to make this animation last a little longer, say 10 seconds, and I want it to repeat, so it's going to go from the left-hand side to the right-hand side of the screen, then back again. So make sure that you have the start position and the end position of the animation in exactly the same place. This will prevent your enemy from jumping around the screen awkwardly. Then I will move the enemy up and down as well at different places so it sort of jumps around smoothly. And there you have it. The enemy is moving around the screen whilst simultaneously pointing its weapon at the player, whilst simultaneously spinning on the spot. So that's two separate animations, both that affect the enemy, but only one that affects the weapon. So the weapon is free to point towards the player at all times. Without anything firing from the gun though, there's not going to be much of a game, so next thing to create is a bullet. And again, I'm just going to copy paste the player, remove the player script, change the color to white, resize the player to make it smaller, and rename it to bullet. I'm going to stick that in front of the cannon just so I can sort of line it up nicely. And then I'm going to change the box collider to a trigger and add a quick script. I'm just going to say that void on trigger enter 2D destroy this game object, so the bullet, if it hits anything. And look there, it falls down, hits the ground. Fantastic. Now, falling isn't really an effect I want for the bullet, so I'm going to change the rigid body 2D mode from dynamic to kinematic, so I'm controlling it entirely from script. And you can save the bullet as a prefab to use later. And then I need a script to control how often the weapon fires. So I'm going to add a script to the pointy end of the weapon. I'm going to call it the weapon auto fire script, and it's going to take a public game object, the bullet, prefab, and then I'm going to take a public float, reload speed, make that 1, a public float, a bullet speed, call that 10, and a private float, a reload timer, set that to 0. So whilst the bullet's on the screen, the reload timer plus equals time.delta time, so it's always counting. And if the reload timer is bigger than the reload speed, I want the reload timer to be reset to 0 and the weapon to fire. So I create a new method, public void fire, and this is going to handle creating new bullets. So in order to do that, I need to instantiate a new game object. So this one I'm going to call new bullet and set that to equal instantiate bullet at this position, so transform.position, at the same rotation, quaternion.identity. I'm going to get this new bullet's rigid body 2D component's velocity and set that to transform.right times the bullet speed. The reason I set the velocity to transform.right is because initially the weapon is pointing towards the right and it uses the local rotation, so even when it's pointing down, it's still pointing right. Plumb everything up and there you have it. The weapon is firing bullets at the player which disappear when the player is hit. That's almost a game, but not quite. The last thing to do is to add a counter, add a timer, and maybe make it a little bit more tricky as the game progresses. And the way we're going to do that is through script. So I'm going to add another script to the player, and this one's going to be controlling the game. I'm going to call it aim game. And within this, I also need access to unityengine.ui because I'm going to be controlling the text elements. So I'm going to start with a public integer. I'm going to call that times shot equals 0. Public text, call that score. Score text. Public text, level time text, public text, best time text. And as the game progresses, I want the animations to increase in speed. So I'm going to get a public animator, enemy spin, a public animator, enemy move to control the spinning of the enemy and the movement of the enemy. Add a private float, Level timer, set that to 0 to start with. Same as the private float, the best time. Also set that to 0 to start with. I'm going to need access to the scripts attached to the enemy and the weapon. So I'm going to say private weapon autofire WAF and private enemy. And then I'm going to go find them when the game starts. So I'm going to say enemy equals find object of type enemy and WAF equals find object of type weapon autofire. Then in the update method, I'm going to get the level timer plus equals time.delta time. So the time's always continuously ticking away. I'm going to get the score text.text and set that to a string which says hits, and then add on the times you've been shot to the string. Same for the level time text.text, call that time, and I'm going to add on the level timer dot to string. And same for the best time.text. It's going to say best time, and it's going to also add on the best time to string as well. So it all displays on the screen in the text elements nicely. If the best time is greater than or equal to the level timer, I want the best time to equal the level timer. So that way the best time keeps track of what the maximum level timer has been. I also need the player to keep track of if it's been hit by the bullet. And as the bullet's a trigger, I'm going to say void on trigger enter 2D collider 2D, which I'm going to call trig. And then if trig.tag is equal to interactive, which is a tag that I'm going to give to the bullet, I'm going to increment the time shot with time shot ++ and set the level timer to 0 again. You need to remember to attach everything from the hierarchy to the script, make sure the text elements are in the correct slots, and make sure that the animators for the enemy are pointing to the right slots as well. You can then give it a go, and it's not quite working as intended. The time is incrementing, but it's doing it in a weird way where I think it's just falling off the edge of the screen there. It's not recording the hits, but that's because I haven't added a tag to the bullet to call it interactive. So let's go ahead and do all of that now. A neat trick for editing the toString function is to add these zeros in, or 00.00. This allows the numbers to be formatted correctly. I also add the tag interactive to the bullet and resize the text elements so that they can display fully on the screen and have a play. There we go, got a hit. The best time updated to 4.39 seconds. And let's see if I can beat my time. There we go. Both the time and the best time are updating. And now that all the elements are in place, the last thing to do is make the game harder as you play for longer. So I'm going to add this make harder function to the aim game script. Now I've had a bit of time to play around with the numbers here, and what I wanted to do was make the weapon reload faster as the game progressed, and I wanted the enemy to look at the player faster as the game progressed, and I also wanted the animations to increase in speed. So what I've done is I've based everything off the level timer. So when the level timer resets, everything goes back to a normal speed, but as the level carries on, everything gets a little bit faster, and you can use your own values here. Just see what works for you. What I've gone with is waf.reloadSpeed equals mathf.clamp, and then I said 1f, take the level timer divided by 500, and then clamp that between 0.1 and 1. I've taken the enemy's look speed and I've made that equal to 50 plus the level timer itself. I've then taken the animator for the enemy spin animation and set that to half of its original speed, and then as the level goes on, you add on the level timer divided by 50. I've done that the same for the movement speed of the enemy as well. But you're welcome to play around with these numbers because it really depends on how quickly you want the level to become more difficult. Once you've got the values you want, add the make harder function to the update method. And you can create a quick flash on the screen by just having a white square that blocks out the whole screen appear for a short period of time. So again, I'll just create a new game object with a big white square, sit it in front of everything in the order in the layer, to set that to 3 or something so it's sitting in front of everything. And then turn the sprite renderer off. And then in script, you can turn the sprite renderer off and on depending on whether you've been shot or not. So first of all, you need to have access to the sprite renderer. I'm going to call mine hit flash, and then I'm going to say that the hit flash dot enabled equals true when it's hit by a bullet. And if the level timer is bigger than 0.1 float, so 0.1 seconds, then you turn the hit flash sprite renderer off again. And in order to access it in the editor, you are going to need that to make that sprite renderer a public sprite renderer. Connect it in the editor. Just drag it across, nice and easy. And that's the whole game complete. If you haven't had a go yet, there's a link in the description where you can play the game online. See what your best score is, post it in the comments. Have a go at making it yourself, or even just crack open the Unity package and have a look around. You can update the sprites, make it harder, make it faster, give it more enemies, more animations, let the player shoot back, anything you like. If you have any requests for future tutorials, just ask and I'll see what I can do. Thanks for watching. If you like this video, please hit like, please hit subscribe, and check out one of my other videos, or even my game, Subspace Shortcuts, which is available on Google Play and Amazon Kindle. I'm looking forward to what you have to say in the comments. I'll see you next time.